display. Okay, the display is, whose laptop is this? So it's not, it's, where's the display?
We have
There's a disconnect between projector and.
press the,
Yeah.
press the.
There you go.
But it's now it's missile on it. Okay. Okay, so I mentioned earlier Cartesian product. So if you see a Cartesian project, and the way you can detect it is if you see a merge join Cartesian in your plan, run for the hills. An example is basically if you have a query from two tables, and you have a condition on one table, and you have a condition on the second table, but you don't have any join criteria between the two, it's going to read all the data, the first table that meets that condition, all the data from the second table, and then basically take the full list and merge every combination, and you're going to produce, basically a matrix. So if there's 10 rows of this and 10 rows of that, you're going to return 100 rows, and it's going to come up with every combination. So generally, you probably don't want to do this kind of SQL statement. Realistically, what you probably do is do two separate SQL statements if there really is no join criteria between them, or it's more likely you forgot to put a join criteria between them and then figure out what it is and do it. So another common thing is using the OR operator. If you have an OR operator in your SQL statement, where I'm selecting from some table where column 1 is something or column 2 is something else. Generally, if these columns are individually indexed, it will actually rewrite the data. The actual optimizer will rewrite to where column 1 is something, union, select another. However, what you may want to do is if you have a concatenated index, instead of creating two separate indexes, you might want to create one index on column 1 and then column 2. That way it only uses one index and it doesn't have to sort the results that come back. So this, again, the way to tune this simply is to change your index. You could also rewrite something like this for column A, or column 1 is B, just to say where column 1 in just A and B. It's a fixed thing. There's nothing to actually execute here. So you're not executing a subquery. You just have a set of constants. So you can avoid the sort for the union. That's created. So they're just little things to think about, while you're doing it. It's not that you have to necessarily go to every statement and spend hours analyzing every statement, but if you sort of learn the best practices, when you write your SQL in the first place, you'll just write initially slightly better SQL to whatever benefit that might be. So I have some questions. See who's paying attention. I'll have the candy available. So which of these three statements, this is audience participation time, except for Rukmini, who knows the answers. Which query is probably the best? Somebody. Nick?
C.
Okay. Anybody have a anyone agree with this?
It has the less.
You don't know why.
The shorter the query, the more optimal it is. That's right.
Right. I'm throwing Leo overhand.
Oh, that was nice.
So, anybody have any idea? Or just everyone is shy?
Give people a second.
Yeah.
They're writing. Their optimizers are not as fast.
Exactly. Everyone's trying to quickly Google MySQL database on your phone in order to test it and time it and see what this is.
Somebody has an answer.
Who has an answer?
For B-Bear.
You wrote for B. Okay, does everyone agree?
Yes, why not?
Yes, we all agree. So, you want a lemon head or do you want a mint? Both. Okay, so the answer is B, that's for sure. Because again, here, we're not doing any operation on the column name. Here, we're doing a lower on the column name, or lower. You can't use an index. So that's pretty straightforward. That's easy. Let's try this. So when we use the not in clause in SQL queries, what do we have to do? What technique does the optimizer try to do? I have a not in clause. I told you, remember that slide way back when I told you to memorize that slide?
Does tables come? I don't see
Which one? Nested, yeah. It may be hard to see. So yeah, the answer is C, not B. Nested table scan, which again can be very expensive. When we talked about, you may want to rewrite your not in, to use not exists, or to use a different kind of query. So here's a good question. I have a big binary file, or binary string, or binary image, and I want to insert that into the database. Should I just sort of have a big insert statement? Should I use some sort of stored procedure? Does it really matter? Is there something else I should be doing?
D. Don't use that.
Okay, D is one option.
C.
B.
Or C,
B.
that's another option.
B.
Or B,
Okay,
or A. Very good, okay, so probabilistically, one of you are likely to be right. Very good. Okay, so the answer is B. So if I have an insert statement and I'm putting that long thing into my string, then I gotta convert that whole long binary value, maybe 10 characters or 20 bytes or an encrypted or something like that. I'm converting it to a string, and converting from some sort of raw data into a string doubles the size, increases network traffic, and so on. So typically what you can do is you can bind it to a variable or function, and then store it within a stored procedure. And you can, again, it may be a little, it may be a lot, it depends on how big the data. If we're streaming, 10 megabytes or something, files that we're trying to insert into a raw column, it's kind of different than I just have, 50 characters of something that might be raw. Doubling 50 into 100 really is kind of noise. So just, you have to think about how much effort it is to do the work to create a stored procedure and implement it and define it, if in reality you're not doing very much with it. So, does anyone know what a derived table? We sort of had a derived table in an earlier example, temporary tables. Does everyone know what derived tables, temporary tables are? Okay, so, then I will kind of give the answer away. So a derived table is the result, and we saw this earlier, when you use a select statement as an actual logical table in the from. So typically from, you say from table 1, table 2, table 3. But you can, instead of actually using actual table 1, which is a real table, you can actually put from table 1, comma, table 2, comma, and you can create a select statement, like we had earlier, a select distinct some data. That generates in memory a derived table. And so by using that derived table, we can actually only pull that data once instead of having to pull it in some sort of correlated or non-correlated subquery. So it's a very useful mechanism, these derived tables, when you're writing SQL, to actually save a lot of I/O, make your SQL very straightforward and very simple. Okay, so if I'm looking, so a very common activity is to see if some data actually exists in a table. I don't really need it, I just need to know, does this thing already, is it already out there? So sometimes you just do select count from the table where column name is something. Or I can just say if exists, select star from table where column name is something. Are these the same? Is one better than the other? Does it matter?
B.
B, okay. What would you like for your snack? Yep, everyone gets one. Oh, you have to, it's part of the, yeah, so that's absolutely true. So if I have the count, right, in order to do a count, I'm scanning everything, right, so I'm scanning all the data, and then I'm also, the count, I'm grouping them. So I'm doing a group operation in order to be able to count them. And I'm doing also a count operation, which is a very easy operation to do on a group, because you just look at the elements. So, the other thing you could possibly do is select star from table name, where column name is something, and row num less than 2. So, in other words, just finding the first one, which is kind of doing the same thing as if exists, but it uses the concept of row num. So row num is an operator within Oracle that basically says, find me this many rows, right? So if row num is less than 2, it says this is only the first num. So row num is a logical column that's added as a result of any query. So it doesn't exist in a database. There's no row num column in a table. It's actually restricted words, so you can't use it. But when Oracle executes a query as it starts going through it, so it's going to do the same index lookup here. So if you don't want your SQL to start with if exists, or if that looks too programmatic, they're both things. Now this you probably wouldn't do if you're writing a generic engine to use, SQL Server or MySQL or something like that. So what of the following are sort of a bad habit that you want to sort of make sure you don't do in your SQL statements? So the first choice, changing some column that's the primary key of the table, updating some column that you're also referencing in the where clause, updating some heavily indexed columns, if you have columns with lots of indexes on them, you know, some individual and concatenated keys, or updating some varchar columns in your place of contents, which are small, with something, you know, much larger or small, you know. Which one should you stay away from?
All of them.
Yeah, I mean, well, theoretically, if you don't need to do any of them, you know, don't.
B.
Which one would you stay away from the most?
Exactly.
B.
C.
8.
D.
Thank you. Okay. Repeating will answer the question.
B or C.
The answer is
I'm
B.
gonna go for A.
So the answer is B. So you have to be careful, because while you can update columns that are referenced in a where clause, because the database takes a snapshot, the database then has to go to its redo log in order to see what the state of the transaction was, because you're changing some data while you're going through the query. So you're constantly going from what data is in memory to the data and going back and forth to make sure that what you're at, your state doesn't change. So in general, you probably don't want to update columns that you're not, you know, that's a criteria. You probably want to search for something by key and then update other through another mechanism. So just be very careful about that. It's a sometimes mistake. So which clause in a SQL contract you could eliminate, a SQL statement if you could eliminate, would get rid of sorts? Or which of these things generate sorts?
D.
Sorry?
D.
I can't do, who said D? You're correct. I could try throwing things at you, but I may. You have the guy in front of you. What? You don't want it? I'm deeply insulted. I'm deeply insulted and personally hurt. But you're absolutely correct. So yeah, if you're doing a distinct, obviously you need to sort them to figure out which ones are unique. And certainly if you're ordering things, you're sorting. That's kind of the definition of ordering. And if you like things, if you're using a like operator, then you're just doing a comparison. You're not, doesn't require sorts. Which of these, this is sort of a similar question earlier, which of these was better in performance? If either, does it matter?
B.
B.
B is correct. I don't know who I heard first, so here you get it. And you get one too. Okay? That's correct, yeah. So B, and we talked about this, you know, if you have order ID times 3, you can't use the index. So if there is an index on order ID, obviously you want to use it as well. So I have a trunk operator on a date, and I want to compare some date in the table to sysdate. Well, what could I do to rewrite this so I could actually use, again,
B.
trunk on transdate? Yeah, B. Trunk on transdate obviously wouldn't work very well. What might I be able to do?
What is trunk?
Trunk
The main
basically
part of the
pulls
tree.
out, yes, no, that's with a K. No, it basically floors it and produces the base date. So it could be any operator, you know, we don't have to use trunk, it could be, you know, month or day of the month or something like that. So, and again, you just want to make sure that you pull out, you know, the operator. So you can do transdate or whatever between, and use between. So you basically, the idea is you want, if you have an index on the date, you want to make sure your left-hand side of your query doesn't have any operators. Then you can do it between trunk of sysdate and trunk of sysdate plus 1, if you want to do today.
And the reason is because then the index is used.
Yes, this way you can use the index. Right, so the key is, again, these are all sort of similar, because really this is the bulk of the mistake. I mean, you may have a weird, non-correlated subquery, you know, kind of statement, maybe in your application, but you're much more likely to have this statement in your application. And you might as well do this one more effectively. So it's fun to have that complex slide where you can map really complex statements into other complex statements, and that's an interesting sort of intellectual exercise, but 90% of people make this mistake first. Is there any benefit to using union all instead of union?
It won't seek for equal rows.
Right, so it won't do, yeah, so exactly. So if I'm doing union all instead of just a union, it means I'm pulling all the data. I don't try to eliminate duplicates, and in order to eliminate duplicates, exactly, you have to do a sort. Okay? And if there are no duplicates, you know there are no duplicates, then you don't need the sort in the first place. And frankly, sometimes just your application code, if you know there's only a handful of duplicates and it doesn't matter that you have that, let your application code handle it. You know, and that may be a big benefit. Again, depending on how many duplicates you have and how much sorting you need to do, or if you need to do something else. Also, similarly, in a group, you're using the halving expression. Halving will impose a filter, whereas you can use a where condition potentially to reduce your data set. That's another way to, you know, just make, again, it's not that you have to go tune a statement that has it, but if you're gonna write SQL, you might as well write it the best way you can, knowing sort of the best practices as you start. So there's a lot more stuff to look at that I haven't talked about today, but there's so many things that might be useful as far as tuning. So basically, it's always have a primary key on the table. You'd be surprised how many applications don't have, you know, a primary key, and you do lookups based on like a name, which is a secondary key, and you know, and you won't have the ability to sort of identify individual records. We talked about use a concatenated index instead of two separate single column indexes, because that's much faster. If a query has to go against two, it might use the wrong one. It would have to do two separate lookups and do sort of a nested join. See if there are any triggers in play. So it might be that your SQL is fine, but there are triggers that are on that table or that column that do all sorts of complex logic. And so maybe the offensive stuff is not in what operation you're doing, but the fact that you have triggers on that database table. Be careful about using a foreign key. So if I have a table with 5 foreign keys, and I've defined foreign key constraints, and I insert 1,000 rows, then I'm generating an additional 5,000 hidden SQL queries behind the scene, while the database tries to check those foreign keys. And so those queries are relatively fast, but still, it's something you need to, you know, follow. You know, are there locking issues? So do I have two SQL statements that are trying to update the same record or read the same record? So are they just waiting on each other? It's not the SQL, it's just the fact that, you know, they're both too stubborn to get out of each other's way. You know, do I have some index? And I talked a little bit about this. Does it, you know, is it updated too frequently? It needs to be rebalanced. Does tables have too many indexes? You know, because if you have 10 indexes on a table, then you insert one record, you've got to update 10 index records. So that's just a lot of writing and reading. Do you generate chaining? So for example, do you have a varchar 2 column in a table that, you know, starts off really small and it grows big and small and stuff, and you may end up spreading that data across many different physical blocks. And again, this is really a more obscure thing, it's kind of rare, but if you can manage, there's a database parameter called %free, which basically leaves room in tables for you to actually put in larger data. So it doesn't try to compact everything optimally with no space, so you have sort of a database record, which is here, and then because I put in a big string in the middle, and there's something already here, another record, but I have to chain and point to a record that's stored over here, and the rest of the record then is stored over here. And I'm chaining the storage of one physical record in the database. So that's a possibility. Again, pretty unlikely. You just sort of, that's something, your application you don't change. That's just sort of, earlier we talked about how you deploy your database itself. And again, can use stored procedures to reduce the amount of I/O. So if you're reading from the database, that earlier example where I'm reading thousands of rows and doing calculations, but at the end of the day I'm only returning about 10 records worth of information, why read all that data into your client or into your app server to do all those calculations, when if the calculations themselves might be small, let Oracle or, you know, or any database engine do the calculations for you, and you don't have to move all that data all the way over the network to wherever your program is running in the app server in order to do all those calculations to throw away 99% of the data. Let the database do it, it's all kept sort of locally, does its calculations and gives you just the subset of the rows that you need. Other things. So if you have queries, you know, that you're doing 5 table joins or 4 table joins, maybe you should break them down into smaller queries where you're querying against a couple tables at a time. And, you know, because every table you add is just another set of data that needs to be sorted, merged, looped through. So again, just be careful when you're writing queries, you know, how to break it down. Again, that's knowing your application. Be careful if there are other threads that are writing or updating data that might be in your select statement, because then you're going to have to go to the rollback segment in order to get read consistency. So if I'm scanning tables that a lot of other threads in the application are updating, I remember when I do my select, it has to be read consistent at the moment I'm doing select. Doesn't matter how many updates or commits have happened behind the scenes. So I have to look at the rollback segment where I capture all those delta information in order to make sure my statement is consistent. So you may want to denormalize data, you may want to summarize data. If you denormalize data and slide something into a parent table, maybe you can eliminate a whole join instead of tier, that might be beneficial or useful. It may eliminate the ability to sort or group by. For example, if you have information about many addresses, let's say you have a record that talks about a customer and it's got 10 addresses. And you've got a primary address. Rather than having in the address table a flag that says primary, maybe you have in the parent record a key that says primary address key, and it points, and that way you have that information in one row. You don't have to do a query and a search against the second table and looking for a flag. So that will save you lots of sorts, an extra table look, a join. We're getting much less data. And there are probably 100 things that I haven't even thought of here that come into play. Also, maybe think of at the application level. Don't even worry about SQL, Maybe I can just cache the data in the application memory so I don't have to do all these just-in-time lookups. Or maybe I can fetch additional off-screen records asynchronously. So if you have some UI where you're displaying only the first 10 rows of something or the first 15 rows of something, maybe read quickly, fetch 15 rows, and then in a background thread, fetch the next 15 or the next few pages, maybe stop yourself at 3 pages or something. Because typically, depending on, again, the application you're using, your users will only look through maybe the first screen's worth of data or the first and second screen's worth of data, particularly if it's sorted and pulled out, maybe most recent or by priority. So you can use some background so you can return response to the user much more quickly. Fetch data upon startup of your application. That's, again, stuff you can cache. All sort of generally good habits to do. And you have to just be very careful. So there's a lot of numbers when you run plans and you get to see all these different execution counts and statistics in the database. You have to just be careful. Don't just blindly follow the numbers. You have to kind of know what they mean and learn and know what they mean. And that is it. Any more questions? Well, thank you very much then.
I have not a question, but I have a comment.
Okay.
So,
So a question and a comment combined is called a quement.
question, comment.
It's called a quement.
A comment.
Yes.
So, for the developers here, I mean, there's definitely a lot of benefit to knowing about these things and kind of trying to follow them.
Sure.
But for those of you in QA, take all of the little things that Steve said not to do, and just go ahead and do a text search against the code base.
Right.
And you might find the performance issues before anybody has to take out a tuner, take out a profiler, or take out a load runner, a load testing tool.
Right. Right. I mean, what I mentioned earlier as a mechanism, this is very common, is, start your data. And again, this is in test mode because you don't have volumes of data. And what you can do is you just sort of run through your tests, which will execute theoretically all or most of the most common SQL statements in the database. And then look in the database itself at what SQL, you can go into that $SQL area, and you can pull out every SQL statement that was executed. So you can then see what they were. And then you can just write a loop for every one of those to create run explain plan with a little script to pull the plans out. And you have that, you have a big file, and just do searches for full table, boom, full, range scans, is there anywhere the word Cartesian? That's a gotcha. So you can basically search for a few things very quickly to find, or is there doing and equals? I haven't talked about that. That's kind of another expensive kind of operation that the database does. So what Leo said, yes, you don't have to have large volumes of data and run the application for hours. You can just sort of look and just at least see the most obvious low-hanging fruit. Easy things, or maybe a simple index or a change in index might knock out some of those. And indexes are easy to build. You don't have to change any application code. You don't have to do anything fancy. It's a very straightforward way to do tuning at a low cost. Typically, you're not going to be focusing on some really complex stuff. Typically, you're going to find a couple of easy things that, oh, oops, we didn't do it this way, or oops, we were in a hurry, but we did it one way. Yes, question in the back? No? Okay. You're just waiting. Yes?
Does the Oracle support, for example, some hints how to optimize your queries by using these statistics?
Yes, so Oracle does have that wizarding.
SQL wizard. right?
Yeah, the SQL, there's a wizard that you can run through Oracle, either through the admin panel, you might be able to do it through SQL Developer, which is sort of Oracle's tool. So you can actually look at different statements and it will try to give you suggestions, like if you have these weird correlated subqueries, not correlated subqueries and stuff. So yeah, it's not perfect and it doesn't know your data, but it can at least try to suggest for things that are expensive, alternate ways to rewrite it. And frankly, it's smart, so it does use some of that under the covers. So it will rewrite, like if it sees a minus, it will rewrite that for you, for example. And if for a couple of the other different scenarios where you have, two queries, it will change that to an in if it's on the same column and it happens to be an indexed column. So it will do some of that basic stuff for you. But there is, that SQL wizarding.
And if that doesn't work, call Steve.
And if that doesn't work, call Steve. My name is lsegal@selectica.com.
Okay, and the following
Yes.
question is,
Yeah.
does Oracle provide, for example, mathematical solution? I want to say, for example, always use optimization by itself, and Oracle will work like, for example, some network which will all the way optimize itself. For example, but by the statistic, if we can found the bottlenecks,
Right.
and by itself reduces bottlenecks.
Yeah, I mean, it will do its best. So as the statistics get better and better represent the distribution of your data, so if you have only a few thousand rows in a table, then maybe the distribution, from its sampling. And again, you could have it, when it gets statistics, you could have full statistics run on a table. You could have sample statistics where it pulls out a random subset of data. If you don't have a large volume enough of data, then the statistics it gets initially will not be a fair representation. So it does recalculate. You can tell it to recalculate statistics, and then once it has a better distribution, it will know and produce a better plan. Maybe go to this index first and then this one, or drive with this table, because they're, and then use the join against this table, and maybe it reverses it over time depending on how the data plays out. So Oracle is fairly smart about doing that, but it's far from perfect, but it's generally pretty smart.
I mean, more good. Is it able to do without the human, without the developer?
Yeah, this is what it does, Yeah, so if you tell it to sample, resample statistics, or every so often configure it to recalculate full statistics, it will regenerate statistics for a given table, and then depending on the statistics, may produce a different path. And may say, like I said, drive with this table and its indexes, and then join with this table. And if the statistics down the road, the new set of statistics, so the other way, it'll drive with this set of table. This is more restrictive, produces a smaller set, and use that to then query the second table. So it will self-correct, yes.
So it seems it should have some test environment for maybe some synthetic tests, just to make sure that everything go correct.
Yeah, but again, it comes down to the way it uses statistics is based on larger and larger volumes of data. And so even if you're running a benchmark, it's very hard, it's very rare in benchmark to get really a perfect balanced distribution of data, because you're generating large volumes of data. You want to hit 1 million records in this table and 100,000 in this table. But it's hard to necessarily guarantee that the distribution of the content of that data will match what happens when you really run the application down the road. So you kind of all have to do the best you can. And the database tries to do the best it can. As it looks at what it is, it tries to make its best guess. I mean, it's no more perfect than we would be if we looked at every statement and drew out the full plan and said, Oracle, you go do this.
But for example, Oracle says me, oh, you have a problem here. Try this hint. I said, okay, Oracle, I'll try it. But